we're going to talk about some of the problem-solving strategies that kids use. And so one thing I want you to think about when you're thinking about these strategies is we are actually letting kids choose which strategies they want to use, okay? And the reason we're providing them with that choice is because they are at different levels of developing understanding, okay? In any mathematical concept, we always start with direct modeling, okay? And direct modeling is when we use either physical objects or drawings to solve a problem, okay? So in all mathematical concepts, we always want to start with direct modeling. Now, sometimes people get this confused with learning styles. And the truth is this has nothing to do with learning styles. And in fact, the theory of learning styles has lots of research that actually disproves it. So this is not about kids preferring to learn with objects. This is about, we know that research tells us that kids do learn mathematics best when they start with objects, okay? So this is like an everyone thing. We all learn math best when we start with objects. And then we move from objects to drawings. And so drawings are basically just a representation of objects. And so those are all called direct modeling, okay? So we call it direct modeling. And when kids are direct modeling, they use something called a counting all strategy. And counting all means, just as it says, they count all. So if they were adding like 3 plus 2, they would count out 1, 2, 3, and then 1, 2. And then when they find out in all, they have to go 1, 2, 3, 4, 5. So they have to count everything. So they count it and they count it and they count it all again. So that's direct modeling. So after they have lots of experience with direct modeling, they start to move on to something called counting strategies. And if I were to name this more clearly, I would call it mental counting strategies, all right? Because they use counting when they're direct modeling, right? But this is like mental counting strategies. So, for example, if you're adding 3 plus 2, you might see a kid put 3 in their head and they say 3, 4, 5, and they count on. Right? So they don't have to start at 1 and count all. They start at one number and they count on if they're adding, or if they're subtracting, they start at a number and they count backwards, okay? But they're using a counting strategy. And so remember, this is mental counting. If I were to add an extra word, I call it mental counting strategies. So they start with direct modeling. Then they use those mental counting strategies. And then sometimes they come across problems that they already know the facts, okay? And so we have this category called number facts. And there's 2 types of number facts. The first one is called known facts. And known facts are, just like they sound, facts that kids just know. And so, for example, in kindergarten, kids often just know doubles. Like, kids just think doubles are cool. So they memorize those as known facts really early on. Also, they usually know their plus ones, right? Because it's just the next counting number. So they memorize those facts first. They also then take facts they know to find out new facts. And we call that derive. So make sure you have that word in your notes, derive. So when we derive a fact, it means we use a fact that we know to find a fact we don't know. For example, if I didn't know what 2 plus 3 was, I could think about, well, I do know that 2 plus 2 is 4, so 2 plus 3 must be 1 more. So I just derived that fact from a double. I'll say that again. So if I knew 2 plus 2 is 4, then 2 plus 3 would be 1 more, which is 5. Okay, so the idea is I'm taking a fact I know and I'm wiggling it around. I'm deriving it to find a fact I don't know. So what really happens with kids, and I can see my 2nd grade son right now using all of these. So like if it says 5 plus 6, he goes right over here to number facts and he's going to say 5 and 5 is 10 and 1 more is 11. He's going to go to a derived fact, okay? However, if you say 8 plus 3, he tends to use a counting strategy and he'll say 8, 9, 10, 11 and count on in his head. He'll put the 8 and he always touches his head. 8, 9, 10, 11. He holds up his fingers as he counts, okay? And then sometimes with his subtracting, he'll end up drawing a direct model and actually drawing objects and then like crossing them out. Okay. So even though he's a second grader, he's using all of these strategies based on the numbers and the situation. All right. So that's what we want kids to do. However, as teachers, of course, we're always wanting them to be even better, right? So if I have a kid who is always using direct modeling, I might want to pose questions. They're going to push them into using some counting on strategies, right? So like, how could you take what you've done here, and instead of counting all the way back at 1, could you start at 7 and then count from there? So I'm trying to just move them to nudge them along as I can. All right, so let's talk about these one more time. So I just told you that there were direct modeling strategies. And I told you that kids tend to use direct modeling with objects and direct modeling with pictures, okay? By the way, kids also walk around with direct modelers on their body, their fingers, right? So sometimes if kids are using direct modeling, my son will say, will you show me 7 fingers and I'll hold up 8, and then we'll figure out how many there are all together. So like they'll even use each other's fingers for direct modeling, all right? So when they're solving that problem, that means they have to use something to represent each one of them. When we move on to counting strategies, it's more efficient, right? You get there faster. Kids most commonly use counting on, that's like the counting forward. Sometimes they use counting back, but it's much more difficult for kids. So sometimes they don't take that on until like 2nd grade or end of 2nd grade. Now here's a little tricker. Kids also use their fingers when they're using those mental counting strategies. For example, like this little picture shows, they might put 5 in their head and count on 6, 7, 8. So they're using their fingers in this case to keep track. Okay, so those fingers are used to keep track. And notice they didn't hold up 5 fingers and then 7 fingers. That would have been direct modeling. They just said, I put a 5 in my head and I counted on 6, 7, 8. They might also model like this and actually build the 5 and the 3. But when they figure out how many, they say 5, 6, 7, 8. All right, so they don't count on one by one. They don't count all. They count on. They're like 5, 6, 7, 8. All right, those are counting strategies. And finally, there are known facts or derived facts. Sometimes they use something called doubles. They learn those really fast. They also use the adding one more and also one less is very common for them just to know those very quickly. Kindergartners also memorize the facts for making 10. So that's a known fact that a lot of 1st graders are going to already know is how to make 10s. So once they start learning some facts, then they can use those facts to find out facts they don't know. And we call that deriving facts. That's using facts I know to figure out facts I don't know. All right. So some common things that kids use to derive. We already talked about doubles, which is like if I want to know 4 plus 5, if I know 4 and 4 is 8, then 4 and 5 is going to be one more, which is 9, right? So that's a pretty easy one to derive. Now this 10 as a benchmark may take a little more for you to wrap your head around. Okay, so if kids are asked what is 7 plus 9, what they will do is by using 10 as a benchmark, instead of thinking about a 9, they think about that it's easier to add 10, right? So how can I make that 9 into a 10? I just need 1. So I can basically break apart my 7 into 6 and 1, okay? So I'm going to like take 1 from that 7, add them to make a 10. And so now I've got a 10 and a 6, which is 16.